Welcome to Criterion D. This section has two questions. Answer all questions. Question 1, you will apply the concept of form in answering the following question. Numbers can be represented in different forms, and scientific notation is one of them. So remember, scientific notation, you learn it right in year 7. And you will also meet it in a bit of it used in year 8 to represent various forms of numbers. So our understanding of our own place in the universe has developed over time, often influenced by personal beliefs rather than scientific evidence. While Nicolaus Copernicus is credited with formulating the current model of our solar system, a Greek astronomer, Aristarchus, promoted the idea of the sun being at the center of our universe about 1,800 years earlier. Johannes Kepler was the first to propose the laws of planetary motion that are still in use today. The distance between the Earth and Mars is constantly changing as the planets rotate about the sun. The smallest distance between them is 54.6 million kilometers, and the greatest distance between them is 401 million kilometers. The fastest spaceship to leave Earth was NASA's New Horizons with a recorded speed of 58,000 kilometers per hour. Use this information to answer the following questions. Part A, write the smallest and greatest distance in scientific notation. All right, so our smallest distance is 54.6 million. 54.6 million kilometers. So I'll write smallest distance. So writing in scientific notation should be in the form of A multiplied by 10 raised to K or N. And there's a condition I give for this, that A should be between 0. Let me just write that down. Rather between 1 and 10. So now we can write 1, and then we can write that sign, and then we write A, and then that sign again, and then we write 10. So should not be equal to 10, but it should be less than 10. Let me look for the other sign. This one, 10. So it's not a must you write this, but that is how scientific notation is given. Then K is any real number. All right, so our A should be a number between 1 and 10. 54.6 million is the same as taking that number and multiplying it by 6 zeros. So if you multiply it by 6 zeros, it is the same as saying 10 raised to 6. So that is what 56 million is, 54.6 million is. But this one is in the form of scientific notation, but it has a problem on the value of A. A should be a number between 1 and 10. And look at what we have here. We have 54.6. So how can we make it a number between 1 and 10? We'll move this decimal point from where it is back to where 5, and between 5 and 4, and it will be 5.46. That is a number between 1 and 10. Then times 10 raised to, because you have moved back once, we are going to add the power, and so that we will have 7. So instead of 6, we'll have 7. If you want to confirm your answer, just you can move this side, or later on we'll confirm that using our calculator. So the smallest distance in scientific notation is given by that. So smallest distance goes to that. So the greatest distance, you're going to do the same thing. Greatest distance is 401 million. So greatest distance is equals to 401 million. So million has 6 zeros. So this should be the same as 401 times 10 raised to 6 times 10 raised to 6. Now we need the value of A to be a number between 1 and 10, but this is 401, is way beyond 10. So we are going to ask ourselves, how can we make this number to fall in, or to be a number between 1 and 10? And this means from outside here, from where 1 starts, I can put my decimal point in 1, 2, the second step, which is the same as 4.01. So you move back 2 times, you make that a number between 1 and 10. So 4 is less than 10 times 10 raised to, now we had raised to 6, but we have moved back 2 times. So our power will change to 8. So I can write greatest distance is equals to that. Then you can put units, they were in kilometers. Then after you do that, you insert your answer there. So this is D3. You'll get 3 marks for doing that. And then let's look at question B. For 2.2, calculate the minimum number of hours the ship will take to travel from Earth to Mars when the planets are at their closest to each other. Write your answer in scientific notation. Then use the formula times equals to distance over speed. So you'll go directly to the formula, since time is given by distance divided by speed. So they'll need the number of hours it will take to reach the closest to reach Mars when they are closer to each other. Now, when they are closer to each other, that means we'll use our smallest distance, and our smallest distance was 54.6 million, or you can use scientific notation, which was 5.46 times 10 raised to 7, and then divided by, so I just need to copy everything so that I put it as a fraction. So that divided by speed. Speed, they've told us it is 58,000 kilometers per hour. That is the speed the New Horizons takes to reach that. And you can also put that as a scientific notation, which will be 5.8 times 10 raised to, so count how many steps do you take to reach 5.8 is 1, 2, 3, 4. So raised to 4. So at this point, it is not required that you use the scientific notation, but You can also do directly via you can do it directly via use of this other notation, the normal notation. So you can insert this, and if you need to do that math, you click your calculator. Let me check. Then you're going to do, you just click up here. There's a calculator, you click the calculator. And then because you are inserting a fraction, you choose A over B. In the numerator, you're going to write 5.46 multiplied by 10, raised to, you click A raised to B, which is power raised to 7. And then on the denominator, we'll have 5.8, 5.8, not 58. So 5.8 multiplied by 10 raised to 4. You get your answer as 941.37. So you can convert to a fraction if you want, but you can also leave it as a decimal. And if you want a visible calculator, you can use it as a full screen. So let's return back. So we are going to insert this. Remember, we already wrote it, and then we are going to click. I'm going to click here, and then you can click here, copy from calculator. And if it doesn't copy, you'll wait for it. It's still loading. Yes. So it writes, or it gives you what you have done, and gives you the answers that. So we'll need our answer to 2 decimal places, unless they have told you to do otherwise. 2 decimal places, that will be 94. So we'll say time is 941.38, which is the same as, because they want to answer in scientific notation, it is 3.9.4138 times 10. Let's write on this other side. You can close your calculator. So let's write what we have written here. We cut this, bring it to this other side, then write times 10. Times 10 is to my laptop charge. So times 10 raised to, how many times have we moved back to get 9.4? We've moved back to times. So we're going to write times 10 raised to 2. And then you insert. That is your answer. So you can either do this in the calculator rather than writing here. And then we'll copy it, put it there, and give you the answer. All right, look at part C. Calculate the minimum number of days the spaceship will take to travel from Earth to Mars when the planets are their farthest part. So you are also, days is time, so you are also looking for time. You're going to use this formula we have used here, and say time is equals to distance over speed. The greatest distance was 4.01 times 10 raised to 8 kilometers. So we are going to write 4.01 times 10 raised to 8 kilometers 0.01 times 10 raised to 8. So that is it, then divided by, and write this division sign. Speed is 58,000, but you can write it in scientific notation. Let me use brackets so that it makes my work look presentable. So 5.8 times 10 raised to times 10 raised to 4. Okay, so this is what you are supposed to write. So this one divided by this. You can insert that meanwhile. Then you will go to your calculator, pick the calculator here, and then you're going to write as a fraction first, and then you're going to write 4.01 times 10 raised to 8 times 10 raised to 8. It should be raised to 8, then divided by 5.8 times 10 raised to 4. Okay, so you will get this as your answer, and you are going to come here. You're going to come back here. You can close your calculator, then come back here and then say copy from the calculator. Let's click. Your calculator should be visible. I think everything we did has been erased, but let me do it quickly. 4.01 multiplied by 10 raised to 8. We need to put the sign, but don't worry about that. I can start. If I forget, put the fraction sign, I can put the brackets, and then I just use the division sign, yes, and it will bring my division sign there. 5.8 times 10 raised to 4. Okay, so we can have that, and then you can click here, copy from calculator, and wait for it to copy for you what you have done. All right, so we'll give you that answer. And then what you're going to do is you're going to, because this is hours, remember, and if you divide, you get hours. You can copy again since it looks like it has disappeared. So since this is hours and you need days, you ask yourself how many days will give you this number of hours. So we know that one day will give us 24 hours. 6913.793 hours will be how many days? So you can still use your calculator here. You press answer, and then you can write divide by 24, because that is the conversion between hours and days. So you see the calculator gives us 288.07. So that's just 288 days. So you write that and you score your mark. Alright, so in this question, you'll apply the concept of relationship in solving problems involving the Pythagoras theorem. Telecommunication tower means all types of towers, including but not limited to a monopole, tripole, lattice tower, guide tower, self-support tower, pole, mast, or other structure, which are used to support one or more telecommunication antenna for the purpose of radio telecommunications and which may be located at ground level or on the roof of a building, and may include an equipment shelter containing electronic equipment and which is not staffed on a permanent basis and only requires periodic maintenance. One such tower is placed on top of a building whose height is 8.0 meters. So CBC in the depth. So this is the ground, and then this is the top of a building. This is a building, and then we have the tower, which is from C to D. So building is BC, they are saying it is 8 meters. So standing at point A, you can see the top of the building, which is point C. So you are standing at point A, you see the top of the building, point C, and the top of the tower, which is point D. Point B is at the base of the building and is on a flat ground from point A. So point B is flat ground from point A. It is estimated that the angle BAD, the whole of this angle is 60 degrees, and angle CAD is 45 degrees. Describe a strategy that you can use to work out the height of the telecommunication tower. So this concept or this question tests the concept of trigonometric ratios and how you can use it. So that should be one of your strategy you're going to use to solve this this question. So the first thing you can write is using trigonometric ratios, I will obtain length AB first. So you need length AB. This one is using 8 meters. 8 meters is length BC, and angle. The angle that point A makes with B and C, that angle EAC should be the difference between the whole angle, which is angle A, BAD. So let me write it in a bracket. So, and angle BAD minus angle CAD. So if you subtract CAD from BAD, you're going to get the angle BAC, the smallest angle, which is from the smallest triangle we see here, triangle ABC. So we will get 15 degrees. So which is using 8 meters and angle 15 degrees. How is it coming to 15? It is 60 minus 45. 60 minus 45 is 15. So once you get B, so we'll say once I obtain side AB, I can use trigonometric ratios to find side BD using angle. So which angle is BD being used for? So it is angle BAD, and which you have been given using angle BAD, which is 60 degrees. So you write that and then you score your C2. All right. So by use your strategy to find the height of the telecommunication tower CD. So there are so many ways. There's another method of finding this. Some can use Pythagoras theorem after using trigonometric ratios, of course, and then they can be able to get BD. So let's see. We first say that we are going to use, we're going to find the length AB using BC and angle this. So the angle which is here, angle BAD, is being faced by side BC. So side BC is opposite that angle, and then side AB is adjacent to that angle. So which one between the three trigonometric ratios are we going to use? The one that has opposite and adjacent. You realize that that is TOA, TOA, so TOA. So you're using TOA. So we'll say tan 15 is equal to opposite, which is BC divided by AB. And we clearly know that BC here is 8 meters. So that is what we'll write down here. So you're going to write tan 15 degrees is equal to side BC, which is 8. Let me just write BC is equal to BC over AB. All right, good. Now you can rewrite again. Then you copy, then paste it down here. I want to paste it. So BC is 8 and then over AB. So how do we calculate AB? You will cross multiply AB times tan 15 is equals to 8. So we'll write AB tan 15 degrees, tan 15 degrees is equal to 8. Okay, and how do I obtain AB now? So for me to obtain AB, I have to divide every side by tan 15. So divide this side by tan 15, divide this side by tan 15. And you will get your answer as 8 divided by tan 15. So tan 15 degrees, you can use your calculator at this point to get the answer, but because you need to use the exact value for AB, there's no need of writing the answer at this point. But you're gonna come here, because you have AB, which is 8 over tan 15, you're going to use your second strategy is once you obtain AB, you can use trigonometric ratios to find side BD. That is what they are looking for. They want us to find the height of the communication tower CD. So you're going to find BD from B to D, and then you will remove so that will be your next strategy. After you find BD, you say then I will subtract, then I will subtract this. Let me just push this one up, then I will subtract this. I'll subtract 8 meters from this value. Subtract, yes. So you come here, we are still continuing. We are supposed to get BD. And how will we get BD? You'll see this angle here, angle A. BD is the side which is opposite to it, and AB is the side which is adjacent to it. So we can also use tan, and you can say tan 60 degrees is given by opposite, which is BD, opposite, which is BD, divided by adjacent, which is AB. All right. So I can copy this and paste it so that I can write what BD is. BD is what we are looking for, but AB, I'm going to write the fraction. AB is 8 divided by 15 degrees. Okay. All right. So what do you do to get the BD? You're going to multiply all this in the denominator with tan 60. So you'll have BD is equal to, you can just copy instead of writing, copy, paste it there, then times tan 60 degrees, 60 degrees. So you only need your calculator in order to do this. After this, you're going to write the answer. So, and once you get the answer, let's insert this one first. So after you insert that, you're going to use your calculator and you're going to say, I'm going to put the fraction 8 over 10. So you will come here and press 10, 8 over 10, 15. And then you go to this side, come back and close your bracket. Close your bracket, then go here, 8 times 15 times 60. And then you leave it like that, then you come back here. Now you come back here and then you say, you click here, copy from calculator. You give it type copy. Very good. So once it copies, you know that is your answer. Then you will come down here and have some space so you can cancel what is in the calculator, and then you will come and continue or finish. So we said because look at the tower, because we are looking for CD, we said CD will be equal to BD minus BC, and remember BC was 8. So from here we have obtained our BD as 51.712, 51.712.81292, so minus 8. So these are whole numbers. So if you minus 1 from 8 from 51, you'll get 43. So your answer will be 43.71281292. You'll only need your answer to decimal places unless they have stated otherwise. So your answer should be 43.71 meters. Then you're going to insert that. So because it has come in the wrong place, you're going to cut, copy it. Then we want to move this one up. So also ensure the organization is good. It's more, let me copy this image first so that when it deletes, it is okay. And then I'm going to copy this so that my organization is not affected, and then I copy it down there. So copy, yeah. Okay, it has refused to copy. So we might move it by dragging it down, and you can have your answer as that. So if you write your answer as that, then you are good to go. So state any assumptions you made. I think one of my assumptions made is all the points. So all the points will form a right angle triangle, form a right angle triangle. Because for me to use trigonometric ratios, or for you to use Pythagoras theorem, it must be a right angle triangle. So that is one of the assumptions I've made, and you can write it that so that your answer makes sense in real life context, considering that the highest point of the tower must not exceed 45 meters. So the highest for our case, the tower is 43.1 meters. So yes, it makes sense. It makes sense. Why does it make sense? So you will say my value is less than 45. That is 43.71, which is within the required height. Right, so you're done with that criterion D. Let's see how we can do criterion B.